Alright guys, so taking a look at section 3.6, so 3.6 is we're going to look a little bit more at the slope and the y-intercept of this line of best fit. Okay, so here's how it works. Let's see what we got here. So if you remember the equation for the line of best fit, it had this particular format. It had y hat equals a plus bx, where a is a number and b is a number, and a was the y-intercept and b was the slope. But what does that mean? So we're going to kind of investigate this a little bit more, taking a look at this right here. So this is the protein one. I had to recreate it here on my own. But so what's going on here is we have we have the line of best fit drawn in here. They gave it to us right here. So the predicted rating is 28 plus 6 times the amount of protein. And so that's what the equation of this line is right here. And so what they asked us to do is, well, let's use this line to predict, we have like a mystery cereal over here. And so what if this mystery cereal had 2 grams of protein? What would the rating be? So what we can do is we can plug that 2 in. 2 is like our protein, so 2 is like our x. We can plug in that 2 into this equation, and it will give us the point on the line right there. Okay, so we can do y hat equals 28 plus 6 times 2, because 2 is like our x. Okay, our x is our amount of protein, 2 grams of protein. So that would be 28 plus 12, so that would be 40. So that means that a cereal of 2 grams of protein would have a predicted rating of 40, which on this graph would be right about, which should be right here, right where 2 crosses the line. I know my axis is not exactly perfect, but it should be right there where 2 crosses the line. Okay, so right in that spot, right there. Now the issue with that is that when we say that, how confident are we in that prediction? We're going to get this line at this point exactly right here on the line, but the issue is now we know that it's spread out pretty far. The actual cereals that are recorded on here kind of spread out way up here to way down here. So even though we get a prediction right here, we're not all that confident in that, because we know that in real life the cereals had a range from way up here, way down here. All the ones that had 2 grams of protein were in this big range, and so we know kind of that we predicted it here, but it could be up here, it could be down here, it could be down here. We're not all that confident. It could be off. It could be pretty far off from that, unfortunately. That's the best we can do. It's the best we can do, So, but I mean, we know that it's going to go all the way up to, looks like 70 or so, all the way down to almost, what's that, to about 25 or so, give or take. So somewhere in this range is going to be there. And the 40 is in there, the 40 is right there, right on the line. But even though we get 40, we can't be that sure of what it's going to be, because it's so spread out. Now something else that ends up happening is, well, what if a cereal has 6 grams? Okay? If it had 6 grams, we would predict that it would be right here. So let's plug in 6. Y hat equals 28 plus 6 times 6. So that's 28 plus 36, so that's 64. 64 is going to be, if you look at 6, it's going to be this point on the line. It's always a point on the line when we plug it in, but it would be that point right there. And if you look, there actually were some cereals that had 6 grams of protein right here. There were 2 of them right here. And if we use our prediction line, notice what happens. We ended up with a rating that was higher than the actual cereals. These had a rating of like, close to 50, and we got a rating way up at 64. And so if we use this line, not only is it kind of, are we not sure of how accurate we are, here we kind of overestimated. We got a number that was way bigger than the values that were actually in here. So this line is nice and all, but it's not all that great. And the reason why this line is not a great line is because there's so much scatter in the dots. The dots are so scattered out. They tell us in the book that the correlation coefficient for this is a 0.48. Which makes sense because it is positive going up as protein increases, rating increases, kind of in general. But it's fairly weak. It's only 0.48. If it was like 0.9 or 0.8 or something, then we would be a little bit more. The dots would be closer to the line. But because it's a weaker correlation. The dots are kind of further away, so our line, our prediction we make is going to be, it could be pretty far from the actual data that was in there. If these dots were closer to the line, we could be more confident in our prediction, because the number we get on the line is going to be really close to the other dots that were there. Okay, so that's kind of the issue with using the prediction line if the strength isn't that great. We can't be that confident in it because these are always going to be on the line. And so we can't be that sure what's going on. If this was stronger, if this was a stronger relationship, we could be more confident. But because this is a kind of a weaker relationship, we can't be as confident when we plug it in and figure things out. All right. So keeping that in mind, we're going to look a little closer at the equation of the line next. Okay.